Freefall. Introduction. It is well known that all objects, when dropped, will fall towards the Earth. These objects are under the influence of the acceleration due to gravity. In the ideal case, where air resistance is neglected, such motion is referred to as free fall. In real life, there is always friction between the falling object and the air. This is why the skydivers, after a while, seem to move with a constant velocity. A freely falling object is any object moving freely under the influence of gravity, regardless of its initial motion. Once in free fall, the object will have a downward acceleration equal to the acceleration of gravity. Mass versus weight. Mass and weight are two distinctly different physical quantities. Mass. The mass of an object is a quantitative measure of the body's resistance to being accelerated. Mass is a measure of the amount of matter in an object. For example, a mass of 1 kilogram will experience an acceleration of 1 meter per second square under the action of a force of 1 Newton. This happens anywhere in the universe. Mass is an invariant quantity. The force that the Earth exerts on an object of a specific mass is called the object's weight on Earth. This force is directed toward the center of the Earth. This is the force that makes the object fall with a constant acceleration toward the Earth. On Earth, the weight varies with the geographical location. Bodies weigh less at a higher altitude than at sea level. The Equations of Freefall. We understand free fall as the ideal motion of an object on which the only force that acts is the pull of the Earth's gravitational field. As a result of this force, the object moves with constant acceleration. Galileo Galilei first discovered this fact by observing that two different objects dropped simultaneously from the Leaning Tower of Pisa hit the ground at approximately the same time. The acceleration of a freely falling object is constant and equal to the acceleration due to gravity. The velocity of a freely falling object increases at the same rate throughout the motion. The velocity varies linearly with time. The curve representing the position versus time graph for a freely falling object is a parabola. Air resistance force, terminal velocity. The free fall is an ideal motion in which only the gravitational force acts on an object. In real life, the velocity of a falling object increases until it reaches a maximum value called the terminal velocity. When the object reaches its terminal velocity, its acceleration becomes zero, because the sum of all external forces acting on it is zero. In order for the sum of all external forces acting on the object to be zero, we need a force to oppose the gravitational pull of the Earth. This force is created by the friction between the falling object and the air, and is called the air resistance force. When the object just starts to fall, the air resistance force is very small, but it increases as the velocity of the falling object increases. At a certain moment in time, the two forces acting on the object, the gravitational force and the air resistance force, become equal. And from this moment, the object continues to move with a constant velocity called terminal velocity.